So we're going to start. First thing I'd like everybody to do, real simple. If I give you x cubed minus x to the fourth plus 3x plus 4, right? I want everyone to write this down, and then I want you to, a little notation means take the derivative of it, so I want everyone to take the derivative of this polynomial. Right. All right, so we take the derivative, and so we end up with 3x squared minus 4x cubed plus 3 and a 0, and so we all know how to take a derivative. Yay. Well, today we're going to go backwards, and that's actually the whole point of the semester. Last semester we learned how to take a derivative, and now we're going to do an antiderivative. And so the symbol for taking a derivative, there's lots of ways to do it. You have this dx thing, which means take the derivative with respect to x. How we take the symbol for taking an antiderivative is this elongated s, and I did a terrible job drawing it, but you'll see printed versions that'll look nicer. And I'm going to put a 3x squared, and then I'm going to put a dx. And later on, I'm going to explain where these things come from. But if you see elongated s and you see this dx, these go together, right? Right now, just think of that as notation. And whenever you see this, this means take the antiderivative of whatever this is. And your job is, right? And this is how I want you to think about it. Your life's going to be a whole lot easier if you think about it this particular way. Your job is you need to think of something that when I take the derivative, I get 3x squared. That's your job. So when I look at this and I think, okay, what can I take the derivative of and get 3x squared? The thing that pops into my mind is x cubed. And think about it. If I take the derivative of x cubed, do I get 3x squared? Well, yeah, I do, right? And here's kind of the obnoxious part that I have to talk about. So if your job is to take the antiderivative and you tell me x cubed, I'm going to say, yes, you are absolutely right. If I take the derivative of x cubed, I get 3x squared. Good job. But someone else says, well, what if I say x cubed plus 4? If I take the derivative of x cubed plus 4, don't I also get 3x squared? Well, yeah, because that gives us 3x squared and the derivative of 4 goes away. And then someone else says, well, what about x cubed minus 7? If I take the derivative of this, don't I also get 3x squared? And yes, you do. So how do you give an answer? Well, when you compute an antiderivative, because there's some random constant over here, then what you do is your official answer is going to be x cubed plus c, where you put this c, and this is called, it's just a random constant to take care of all of these random numbers that could happen. So when we take an antiderivative, make sure you put a plus c. And here's the really bad joke. If you leave it off, right, I'm going to take off a point, and so any assessment, I'm going to remember to tell you, I'm going to tell everybody, remember to see your answer. Ba-dum-bump. Really bad joke. I know I can't hear the moans, but I'm trying. So when you take the
Mr. Travis?
yes.
So, so the sign, what's the sign for intervals again?
The antiderivative, I have not mentioned at all that. That's this elongated s.
Then what's the d over d?
The dx is just it goes with it. Right now, to explain where that actually comes from is going to be later. But whenever you're taking an antiderivative, you're going to see an elongated s to the left, and you're going to see a dx to the right of it. And when you see this, that means take the antiderivative of this.
All right, thank you.
Okay. So that's pretty much it. And today we're going to talk about, how do you take an antiderivative. Now, I started with 3x squared because we already kind of knew what our answer was. What if I asked, what's the antiderivative of x to the fourth? Okay. So how do we compute the antiderivative of x to the fourth? So everybody write down that. Now, Here's how I need you to think about this, and it's easy to think about it now, and it's going to translate to some harder questions. How do you take an antiderivative? Well, think about what happens when you take a derivative. Like when you take a derivative, the exponent goes down. So if you take an antiderivative, the exponent better go up. So I'm going to look at this and I'm going to think, well, if I'm going to find an antiderivative of x to the fourth, x to the fifth is a good place to start. Because what I want to do is think of something here that when I take the derivative, I get this. So when I take the derivative of x to the fifth, well, let's see. I take the derivative of this, that's going to give me 5x to the fourth. Now I'm going to compare. When I compare, this isn't quite this, right? Remember, my goal is whatever's here, when I take the derivative, I better get x to the fourth. It's not quite. I got that extra 5. And so what I need to do is divide it by 5. And I want you to think about it now. If I take the derivative of x to the fifth over 5, do I get x to the fourth? Well, let's see. It's going to give me 5x to the fourth over 5. The 5's cancel, and so turns out the antiderivative of x to the fourth is going to be x to the fifth over 5 plus c. Now, just for fun, your turn. I want everybody to compute what is the antiderivative of x to the seventh dx. So again, I want to think about what can I take the derivative of and get x to the seventh. Well, I better start with x to the eighth. And then when I take the derivative of that, that's going to give me 8x to the seventh. Well, I got to get rid of that 8, so I'm going to divide both sides by 8. And if you think about it, the derivative of x to the 8th over 8 is going to give you x to the 7th because that 8 comes down and cancels. And so I end up with the antiderivative of x to the 7th is going to be x to the 8th over 8 plus some constant, plus c. In general, and this is where a lot of textbooks just sort of give you the rule, and in general they tell you if you take the antiderivative of x to any power, some generic power n, then that's going to give you x to the n plus 1, where you add 1 to the exponent, and then whatever the exponent is, you put that in the bottom, and make sure you put your plus c. And so I think pretty much every textbook has this thing. It's called the power rule, or I mean they have other things. Now, here there's some good news and bad news, right? The bad news is taking an antiderivative is harder than taking a derivative, right? A lot of times in math, when you learn to do things forward, you also have to go backwards, and backwards is harder. That's the same thing here. Here's the good news, and I really need to make sure everybody hears this. When we took derivatives, there were things called product rule and quotient rule, right? There is no product rule or quotient rule for an antiderivative, right? Very, very important, right? There is no product, there is no quotient rule. Technically, there is something with a product rule, but that's only for BC. As far as our course goes, there is no product rule, there is no quotient rule. All right? Just sort of throwing that out, and we're going to see some examples of that in just a little bit. So let's practice a little bit. So as far as taking antiderivatives, if I take the antiderivative of, let's do 3x to the fifth plus 2x plus 7 dx. Now, here's kind of the good news with antiderivatives. The skills, one of the big things we did with derivatives, which is what I made you do at the beginning of class, when you take a derivative, you take the derivative term by term. The same thing happens with an antiderivative. Whenever you see, an antiderivative of a bunch of stuff added together, what you do is you think, well, what you want to do is, how do you take the antiderivative term by term? So you want to break this up. Okay, how do I take the antiderivative of this? How do I take the antiderivative of this? How do I take the antiderivative of this? Right? That's one thing that we learned from taking derivatives. The other thing we learned from taking derivatives is numbers in front are decoration, meaning you don't care about them. They're just there. So when I take the antiderivative of this, what I do is I ignore the 3. And then I look at this, and I'll have x to the 5th. Well, the antiderivative of x to the 5th, I add 1 to the exponent, and whatever the exponent is, I put in the bottom. Remember that 3? It's still there. It's just decoration, so I'm going to bring it here. If I look at this, that's 2x. Remember, that's an x to the 1. So if I want to know what's the antiderivative of this, that's going to give you x squared. Whatever this is you put on the bottom. That 2, that's decoration. That just goes here. And then also what's really important, what's the antiderivative of 7? Well, you got to think of what goes here, so the derivative of this guy gives you 7, and that's going to give us 7x. Now I'll clean this up. When I reduce my fractions, this is going to give me x to the 6 over 2. The 2's just cancel, so I end up with x squared plus 7x. And then I've got to remember to put my plus c so I don't lose any points. And incidentally, on Delta Math, when you have to take antiderivatives, and they have problems exactly like this, when they put a plus c, I think they want a capital C. I don't know if they actually tell you they want a capital C, but if you put a lowercase, I don't want you missing the question because you forgot to put a lowercase instead of a capital one. All right. So big idea, and this is actually the main idea today, is that when you take an antiderivative, you only know how to take an antiderivative term by term. Right? So whatever you're given, you want to be able to take the antiderivative of this part, this part, this part, and remember to put your plus c. All right. So what kind of so there's 4 assignments in Delta Math. There's 4 little parts in Delta Math. The first one is similar to this, and actually I think it's even easier than this. I think they only give a couple of terms. They give you a very basic polynomial, and they ask you take the antiderivative. So you take the antiderivative term by term. Remember to put your plus c, put it in, move on. The second one, and this is very similar to things that we did with derivatives. Let's say I give you I ask for what's the antiderivative of x times x squared minus 3x dx. So how do you take the antiderivative of this? First, you don't know a product rule, and you will never know a product rule, so you can't take an antiderivative of it looking like this. So just like we did with derivatives, we want to do this term by term, so I'm going to multiply it out. So that's going to give me the antiderivative of x cubed minus 3x squared dx. And now I can go about taking the antiderivative term by term. The antiderivative of this is going to give me x to the 4th, whatever that is, I'm going to put over here, minus, let's see, that's going to give us a 3. I'll do x cubed over 3. Remember to put my plus c. Oh, I can simplify this, so I end up with x to the 4th over 4 minus x cubed plus c. So rule number 1, and this is a big deal. There is no product rule. So anytime you see stuff multiplied like this, multiply it out and then take the antiderivative term by term. Right? They actually make it a little harder than this. I think they usually give problems that look like what's the antiderivative of x times x squared minus 3 squared dx. And when they do this, smile and nod and just multiply everything out. So the first thing you deal with is multiply this out. That's going to give us x to the 4th minus 6x squared plus 9. Distribute the x, so it's going to be x to the 5th minus 6x cubed plus 9x. Now we've got it to something that we can deal with, so I can take the antiderivative of this, which gives me x to the 6 over 6. Let's see, that's going to give me x to the 4th over 4 plus a 9, and then an x squared over 2. Put a plus c, and then when I clean all this up, I end up with x to the 6 over 6 minus 3x to the 4th over 2 plus 9x squared over 2 plus c. So again, that's all you know. You only know how to take the antiderivative term by term. So given this, multiply it out so that you can actually take the antiderivative term by term. Now on a similar note, what if I gave you the antiderivative of x squared minus 3x plus 2 all over x to the fourth? Sorry, I can't erase. I should have dropped that off. That's just a dx. All right. So I want everyone to write this down. And there is no quotient rule. It's not something you're ever going to learn. BC people don't know something. I don't know something. There is no quotient rule. Right? And since there is no quotient rule, the only way you can take the antiderivative of this is what we had to do when we were dealing with derivatives. Remember in derivatives, when we first started taking derivatives, I said you only know how to handle number x to a power. Well, that's pretty much it today. You only know how to handle number x to a power, so we need to make this look like a whole bunch of number x's to a power. So when I write this down, I'm going to break it apart and say that's x squared over x to the fourth minus 3x over x to the fourth plus 2 over x to the fourth, which is going to give me x to the negative 2 minus 3x to the negative 3 plus 2x to the negative 4. And now I've got it number x to a power, so I can handle it. I can take the antiderivative of this. That's going to give me x add 1 divided by whatever this exponent is, minus 3 add 1 plus 2, right, add 1, and now clean it up. And when I say clean it up, no negative exponents. So to clean this up, this is going to give me negative 1 over x. The negatives are going to cancel. That's going to give me 3 over 2x squared. It's going to give me a minus 2 over 3x to the third plus c. So when anytime you are given a fraction, there is no quotient rule. There will never be a quotient rule. It's just not possible. What you have to do is rewrite it so that you can get it term by term using negative exponents, then take the antiderivative term by term. Okay. The last part I need to talk about is what if I ask for, we've got to deal with fractions. For example, if I say, what's the antiderivative of x to the 3/5? Right. It's nice when your exponents are nice little integers, but we don't always have integers. We didn't have integers when we were dealing with derivatives. We don't have integers when we're dealing with antiderivatives. But that's okay. The rule still works. How do you take the antiderivative of x to some fraction? The same thing. You add 1 to the exponent, and you're going to get really good at adding 1 to fractions. So this is going to give me x to the, that's going to give me 8 over 5. And then whatever your exponent is, you stick it on the bottom. So that's going to give me an 8 over 5. But we can't have our answer with a layered fraction like this, and this ends up being 8 over 5. This ends up being x to the 8 over 5. And once you do a bunch of these, what you find out is whatever this exponent is, you stick the numerator on the bottom and you stick the denominator on the top. And think about it as when you're taking a derivative of this, you want to make sure that the 8 over 5 cancels. So there's no number here. And if you think about this 8 over 5 times the 5 over 8 is going to cancel. And then remember to put our plus c. And the reason I did this problem is that's actually not the problem. That's not the questions they're going to ask on Delta Math. the question they're going to ask on Delta Math is, what's the antiderivative of the fifth root of x cubed? All right, that's what they're going to ask. Well, if they're going to ask fifth root of x cubed, again, you only know how to handle when it's number x to a power. And since you only know how to handle number x to a power, we're going to rewrite this and say that this is going to be x to the 3/5 dx, and now it looks just like that problem. So, the three things that you have in Delta Math,